Everyone, this is the team Hearst, and we will be introducing to you our project for Hearst Call Center Decision Tool. This is our project for the term case at the IEOR 241 course at UC Berkeley. And in the presentation, our team will introduce our project mainly from three aspects: experiments design, sigma modeling, and the statistical regression. We will introduce to you how we did the experiments, how we did the simulation, and how we finally input the data and run the regression. A little bit about the background of the problem. Our project is made for the decision making for a call center. There are three types of clients and three types of agents at different costs, and our goal is to maintain the best service and avoid exceeding queuing lines at the lowest cost. We will make our decisions based on the arriving rate of the customers, and in our case, it's lambda. Lambda represents the aggregate arriving rate of the different type of customers. And for each given lambda, we will return a set of ideal rate level for the agents that we're going to hire. And in our case, that's R0, R1, and R2, respectively for three types of agents. To make it happen, we approach this problem mainly from two parts. The first one is to run the sigma simulation model, and the second is to run the statistical regression tool. In the first part, we went through a dynamic process of hiring and firing, making sure that we hire the right number of people. And the model running time is 200 time units. One of the biggest challenge is to determine the threshold for hiring and firing, which in our case we call it stop tag for each case. And after a series of trial and error, we define our problem and find the ideal stop tags for every round of firing and hiring. And another feature in our product is that we made the hiring and firing process totally automatic. So the user will just only need to start the case by one click, and all the data will be run automatically. After we get the data, and in our case, in total we got 20 sets of data based on 20 different lambda. And then we input the data into our Excel model to determine the relationship between lambda and each R that we want. We tried different types of distribution fit and found that the power distribution is the best fit. And later, my teammate Will introduce to you the details in running sigma model.
So here, as you can see, is a detailed event graph of our sigma model. As you can tell, we ran the model as a parallel system where we have the upper stream up here try to simulate the queuing system of the call center model, and down there at the lower stream we're implementing a real-time monitoring system which will be making decisions on hiring and firing and try to converge the queue. Moving into the monitoring part of the model, we can see that we have in total 9 different modules here. The first 6 modules controls dynamic firing and hiring system, which we use to try to monitor the whole process and try to converge the queue. And the last 3 modules we added there as extra are served as our safety check, because we found that for some of the times when you have an extreme case, the queue might not converge in a short term, or it might actually start bouncing around after you first converge for a short period of time. So we add these 3 extra modules as a safety check to better converge the data. And after running through all the experiment and all the modules, the two will finally be converged, and the system will return our optimal solution for each R. For the output from our model, each R0, R1, and R2 serve as different types of agents, and you can see at the end of the event, when it reaches experiment 10, it'll return us the final optimal agent number we use for each type. And I'll pass this to B to introduce a little bit about how we ran our regression based on data from different sets of lambda.
Okay, as you might notice, we ran 20 simulations. Lambda to the -1 indicates the arrival speed, and R0, R1, R2 simply indicates the numbers of servers in corresponding levels. We use Excel to run all the statistical regression. Using Excel to run all the regression is that there's a whole lot of different models that we can choose from, so we can always find the most suitable regression model by finding the highest R squared. The definition of R squared is pretty straightforward. It is explained variation over total variations. It's a number between 0 and 1, so the closer it gets to 1, the better of our regression model is. So the R square of our cost versus lambda to the -1 is 0.99. It's pretty close to 1. And on the right corner, you can find all the four relationship between R and arrival speed. That will be all for our presentation. Thank you for listening. Please contact us. 15 minutes could save you 15% or more on current course and expenses. Thank you.